Hey everyone, welcome back to the channel. If you're working with Azure and need to manage web traffic, you've probably heard about Azure Application Gateway. But today we are diving into one of its most powerful features, path-based routing. By the end of this video, you will understand exactly what path-based routing is, why you need it, and how to configure it from scratch. So let's jump in. Before we talk about path-based routing, let's quickly cover what Azure Application Gateway actually is. An application gateway is a layer 7 load balancer. And unlike traditional load balancers that only look at IP addresses and ports, an app gateway can actually inspect the content of HTTP requests and make routing decisions based on URLs, headers, and other application level data. It sits between your users and your backend service, doing 4 key things: load balancing the traffic across multiple servers, SSL termination to offload encryption work, web application firewall protection to block attacks, and URL-based routing decisions. And here's where it gets interesting. Path-based routing allows you to route traffic to different backend pools based on the URL path of the incoming request. So let me show you what I mean by that. Imagine that you have a website called example.com. Example.com, when you visit /products, you want that traffic to go to your product catalog servers. Similarly, when you go to example.com/API, you want that your user hit your API servers. And similarly for the images path. So same domain, same application gateway, but different path going to completely different backend services. That's path-based routing in action. This is especially powerful for microservices architectures where different teams manage different parts of your application. Now you might be thinking, why not you use different domain names? So let's talk about the benefits of this approach. The first one is cost optimization, because instead of deploying separate application gateways for each service, you used only one gateway and route intelligently to the different backend pools. Another one is simplified architecture. You only have one public IP address, one SSL certificate, one entry point. Your DNS is cleaner, your firewall rules are simpler, and troubleshooting becomes easier because you have only one entry point. It also has microservices support. Different backend pools can scale independently. Your API might need 10 instances while your image service only needs 2. And finally, seamless user experience. Users never see a redirect or different domains. Everything appears to be part of the same application. Let's break down exactly what happens when a request comes in, because this is important to understand before we start configuring it. So first, the user sends a request to your domain. So let's say example.com/API. The request hits your application gateway's public IP. Then the gateway's HTTP listener receives that request either on port 80 or 443. And then the request is passed to the URL path map, which is the brain of path-based routing. Then the path map evaluates the URL path against its rules, matching from the most specific to the least specific. Once matched, the request is sent to the appropriate backend pool, and the backend pool distributes the request to one of its healthy backend servers. And finally, the response flows back through the gateway to the user. So I'm going to show you exactly how to configure path-based routing from scratch. And before we start, I already deployed 3 container apps using Bicep and an application gateway with the default rules. These 3 container apps represent our 3 microservices, APIs, images, and webs, and each one is up and running. So I already have also the URLs. So let's create and configure the path-based routing to route the traffic to these services based on the URL path. As I mentioned before, I already created all the infrastructure using Bicep, and the only resource that we will be completing the setup is for the application gateway. Currently, the application gateway only contains the listener and the backend pools. So the listener, I will be using the port 80 because I didn't want to handle the SSL certificate in this part. And also the backend pools, we have 3 backend pools for API, web, and images, and each has the full qualified domain name that was provided by default for the Azure Container Application. You could also use a virtual machine skill set, or an app service, and it will work the same way. And the final and key part before we start adding the rules is the HTTP setting. The HTTP setting will tell the application gateway how to communicate with the backend. So in our case, you could have different backend settings for each backend pool, but we are going to use the same. So the backend in my case is already using SSL, so I'll be using the 443 port. And then the other key part here is that we need to override the new host name, because we will be connecting to the application gateway using the public IP, not the host name. So we need to override that, and the way to override that is we will tell to pick the host name from the backend target. So it will go to the backend pool and it will take the full qualified domain name that I specified there. We are not going to use any custom proof for now, just for the sake of the demo. So let's do the important part here. We will add in the routing rule. So for the routing rule, I will use path based, and the priority I will put 10. The listener is going to be my main site, and the backend targets. This is not going to be used. The one that we'll be using is the add multiple targets to create path-based rule. But this is also mandatory. So for the sake of this setup, I will put this one, and I will add the multiple. So I will use API, and then I will use API service, and then the backend setting is going to be the same for all of them. And my backend target, it's going to be my API pool. I will add that. And I will do the same setup for the other path, which is images / and then I will do images service, and then it's going to use the same HTTP setting, and it's going to be redirected to the images pool. And finally, the web service, so it's going to be in the default web service, same HTTP setting, and the web pool. Check that I specify the default one at the end. Remember that if we specify default one at the beginning, none of them will be matched. It will match the most specific one. So with this, we are ready. We will add this, and we will check now the backend health. While this is creating it, we'll check the backend health of our applications. And as you can see, the backend pools are healthy. The rule was already created, so it's time to test this configuration. To test the workflow, we will be using core and our terminal. So I already have the IP, the public IP of the app gateway, and I will be testing the web service, which is at the root. So if you see, it works. So let me do the same for API. It says not found. Let's try with images, and it says also not found. So if you think about it, our backend pools are expecting to receive the traffic at the root level, but we are sending this API and these images to the backend pool also. So that's why it doesn't find it and it fails. So let's fix that in the HTTP setting. So here again, back in the application gateway, we go to the HTTP setting, and the one that has here override backend path, we could say like, okay, override all the path with just the root, because the other backends are expecting also the traffic at the root level. So I will save this and we'll test again from the terminal. So let's try it again, testing the web service, which is still working. This one didn't work, but now it is working. The default one, it's an HTTP bin, so it's working, and the API, it's also working. So as you can see, we completed a demo, we tested it, and it is working. Now that you got the basics down, let me share some advanced techniques. Wildcard patterns. You can use wildcards in your path patterns for more flexible matching. Custom health proofs. Each backend pool should have a custom health proof. Don't rely on default proof. SSL certificate management. When using path-based routing, you typically need one SSL certificate for your domain, but you can configure different SSL settings for backend communication. For example, you can use end-to-end SSL if your backends also use HTTPS, or SSL termination if you want the gateway to handle encryption and communicate with backends over HTTP internally. WAF rules per path. If you're using web application firewall with your application gateway, you can apply different WAF policies to different paths. Maybe one endpoint needs to be stricter with SQL injection, while other more relaxed because of performance. Rewrite rules. Use rewrite rules to modify requests or responses on the fly. You can remove server headers for security, rewrite URLs before sending to the backend, or add custom headers for backend authentication. Let me save you some headaches by covering common issues I see all the time. Path matching order. Remember that rules are evaluated from most specific to least specific. If you put your default rule before specific rules, nothing else will match. Backend port mismatch. If your backend is listening on port 8080 but your HTTP setting is configured for port 80, you'll get 500 errors all day. So always verify your backend ports match your HTTP settings. Health-proof failures. If your backend are marked unhealthy, no amount of routing will help. Check your health-proof configuration and make sure your backends respond correctly. And finally, NSG and firewall rules. Application Gateway requires specific subnet rules, so make sure your network security groups allow that. And there you have it. We've covered everything from the basic of what an application gateway is through configuring path-based routing, all the way to advanced techniques. So to recap, path-based routing lets you route traffic based on URL path, support microservices architectures, reduce cost by consolidating gateways, and create seamless user experiences. So if you find this useful, definitely give these videos a thumbs up, subscribe for more Azure content. I will try to post videos every week covering cloud architecture, DevOps, and Azure best practices. So thanks for watching, and I'll see you in the next video. Bye bye.